Hello friends. So now we will be seeing with the next algorithm, scheduling algorithm, that is your shortest remaining time first, right? So this is a preemptive nature of scheduling algorithm as we have seen in the previous video, that is shortest job first. So that was a non-preemptive nature. So now we will be seeing with the new algorithm, that is your shortest remaining time first scheduling algorithm. The name itself tells that the process who is having the lesser remaining time, the execution time, that will be taking the control of the CPU over there, right? So if you see in this given diagram, right? So there are how many processes? Totally we are having 6 processes, and here you can see the arrival tier time given for process 1 is 0, 1, 2, 3, 4, 5 similarly, and this will be the burst time given for you. Okay, so in the problem, so these are the three things what will be given, that is process ID, arrival time, and they will be giving this process ID, arrival time, and burst time, right? So what we have to come this one calculate is completion time, turnaround time, and waiting time. Okay, so but before that, the important thing is your giant chart, right? So if you draw this giant chart properly, then 100% the rest other things will go in a better way, right? So now let us understand how to draw this giant chart for the shortest remaining time first. Okay, so as you can see over here, process P1 is arriving at 0th time unit, right? So definitely that is the first process which will be taking the control of CPU over there. Okay, but till what time? Till the second process has been arrived. You see there, the arrival time of second process is how much? It is first unit of time. So meanwhile, process P1 can execute on the CPU over here. Okay, seeing this diagram, you can easily understand process P1 is running from 0th second to first second. Okay, here I am taking the unit of time as second only. Okay, for our convenience, right? So it will be millisecond actually, but here for our explanation convenience, let us take it as a unit of time. From the 0th unit of time to first unit of time, P1 is executing. But when we reach to the first unit of time, there is a new process P2 coming into the ready queue over there. Okay, so meanwhile, process P1 has completed its 1 unit of time. So now if you see, the burst time of that will be how much? 7, right? So now when P2 comes into the ready queue, what is the burst time of this? It is 4. So who is having the remaining time, the lesser remaining time? Definitely it is P2. So that is why P2 takes the control of your execution from first unit of time to second unit of time. So when you see here at the second unit of time, right, your P3 comes into your ready queue, right? So now, meanwhile, the remaining time of P2 will be how much? It will be 3. Okay. So now, when P3 is also into the ready queue, now what is the remaining time for this execution? It is 2. So who will win the race? Who will win the race of CPU in P1, P2, and P3? Definitely it is P3 who wins the race because the burst time remaining or the execution time remaining for process P3 is how much? It is just 2. So that is why from second unit of time, P3 takes the control of CPU over here. At the third unit of time, okay, there is one more new process which is coming into existence. Now the remaining time, meanwhile, the remaining time of P3 will be how much? 1 over that, right? So now if you see here, when P4 is coming at the third unit of time, the amount of execution time it reads is 1. So here there is a tie between P3 and P4. Okay, now the question comes, who will take the control of the CPU? It is always we will go with FCFS. That is first come, first serve. Which is the process in the ready queue which is coming first? So definitely it is P3, right? Even P4 is having the remaining time as 1. But as P3 is already in the ready queue over there, So P3 continues for the execution. So now the remaining time for P3 is how much? 0. When P3 completes its execution, now at the fourth unit of time, you can see P5 is also there into the ready queue. Okay, so totally at the fourth unit of time, we have P5, we have P4, P2, and P1. So out of all this, 4, who is having the lesser execution time remaining? That is P4. So that is why P4 is executed after fourth unit of time. At the fifth unit of time, you can see that P6 is also coming into the ready queue over there, and the execution time for that is how much? 2. So when P5 has been executed from the fourth unit of time to fifth unit of time, what will be the execution time for this one, right? So if you see here, P4 is there, okay? P4 has been completed its execution, so the execution time remaining is 0. That means P4 completes its execution. So which all are the processes which are in ready queue now? It is P1, P2, P5, and P6. Who is having the lesser unit of time, remaining time? It is 2. So that is why P6 takes the control at the fifth unit of time till 6 and 7. It completes its execution. So now the remaining time for this will be also 0. So now out of P5, P2, and P1, who is having the remaining time lesser? It is P2 and P5. But if you see, P2 and P5 have equal amount of remaining time over here now, right? So if you just observe P2 and P5, who will take the control? As I have discussed, that is now this tie can be breaked by first come, first serve methodology. So definitely P2 wins the race. So P2 will execute first for 2 units of time, for 3 units of time. Then P5 executes for 3 more units of time, and everything remaining is then taken care by P1. Correct? So this is how the giant chart is drawn for shortest remaining time first alpha. Okay, so that is why we call it as primitive. Why we call it as primitive? Because when the process has been running, we are terminating and giving the control of the CPU for the next process over there. So that is why we usually call it as preemptive. Correct? So now let us come to the actual part, that is completion time. Seeing the giant chart, it is very clear. We can come up with the completion time. See if the what is the completion time of P1? Seeing this giant chart, we can easily say that P1 is completed at 20 unit of time. P2, if you see here, P2 has completed it at, if you see, P2 is here and also P2 is here. So this is the last remaining, what you can say, instructions, or else you can say the remaining time. P2 has been utilized from 7 to 10. So the completion time of P2 is 10. P3, if you see, where is the last? It is here. Okay. P3 has completed at fourth unit of time. Similarly, P4, P5, and P6. Okay, this completion time, it is quite clear that we can easily get to come, we can easily, what you can say, understand it through the giant chart over here. Given. Okay, so it is important for us to draw this giant chart properly. If this goes wrong, so definitely your completion time goes wrong, and completion, using completion time, you are coming up with the turnaround time, and using turnaround time, with that come with waiting time. So everything will go wrong. So that is why be careful while drawing this giant chart. Okay. So now turnaround time. Okay. What is the formula for turnaround time? It is completion time minus the arrival time. Correct. So what is the completion time for P1? It is 20. What is the arrival time? It is 0. Okay, 20 minus 0 is 20, right? So completion time for P2 is 10. Arrival time for P2 is 1. So 10 minus 1 is 9. Okay. So similarly, you calculate all the turnaround times for this. It is P2, P3 is 2, P4 is 2, P5 is 9, and P6 is 2. Okay. So what is the formula for waiting time? If you remember that, it is turnaround time, turnaround time minus burst time. Correct? So this is waiting time. What is the turnaround time for P1? It is 20. What is the burst time for P1? It is 8, right? I'm talking about the original one. 20 minus 8 is 12, right? So what is the turnaround time for P2? It is 9. 9 minus 4 is 5. Okay. So this is how we are getting the waiting time. So what is the average waiting time for this? The average waiting time for this is 24 by 6, which is equal to 4 unit of time, right? So this is what is the expected answer for that. Okay. So usually the problems will be asked something like that. They will be giving you the process IDs. Okay, they will be giving you the arrival time, burst time. You have to draw the giant chart. Through this drawing chart, calculate the completion time, turnaround time, and waiting time. And they will ask you what is the average waiting time or average turnaround time. It is simple. Average waiting time and average turnaround time. Add it divided by the number of processes. 6 here is what? The number of processes, and 24 years. Summing it up, 12 plus 5 plus 1 plus 6, we are getting it as 24. Similarly, the turnaround time, average turnaround time also you can calculate. Sum of all this turnaround time divided by 6, we will be getting the turnaround time for this problem statement. Hope so. It's quite clear to you now. So in the next video, we'll be seeing up with the next coming algorithm. Okay, till then, thank you.